Thor, the Norse god, is virtually an unstoppable super soldier.
But are any of the things he can do actually plausible in the real world?
We believe not.
Thor has a flying chariot pulled by two majestic goats who go by the name of Tooth Gnasher and Tooth Grinder.
They travel at speeds that exceed that of light, taking Thor wherever he pleases.
Can any goats of Earth move to speeds even close to 1,000th of theirs?
To see how Thor's goats compare to goats of Earth, we calculate how long it would take them to travel the circumference of the Earth, assuming they can run at a top speed the whole way.
Thor's goats run/fly at 4.5 times 10 to the 8 kilometers per hour, and the circumference of the Earth is 40,075 kilometers.
You would divide the distance by the velocity to find out how long it would take them to travel the distance.
This means Thor and his goats would travel the world in 8.9 times 10 to the negative 5 hours.
Goats from Earth run at 17 kilometers per hour. Again, you would divide the distance by the velocity to get the time, which means that the goats from Earth would travel the world in 2,357 hours.
To see if goats of Earth move 1,000th of the speed of Thor's goats, you would take the time of the goats of Earth and divide it by the time of Thor's goats to get roughly 26 million, meaning goats of Earth move nowhere close to 1,000th the velocity of Thor's.
Thor's ability to simulate flight by spinning his hammer, throwing it into the air, and holding on for dear life is obviously impossible, but how close can a human get to achieving that?
Thor flies at a speed of 39,000 kilometers per hour, which means, mathematically speaking, he would need to build up enough speed to complete a rotation of his hammer within 6.4 times 10 to the negative 5 seconds.
We calculated this by solving for the period of the hammer's rotations by taking 2 pi r and dividing it by the velocity.
We also solved for centripetal force by taking mv squared and dividing it by the radius.
In the Avengers movie, it showed Thor spinning his hammer 5 times in 2 seconds.
We solved for the period by taking 2 and dividing it by 5, giving us 0.4.
This means that the movie Thor realistically could only achieve a tangential velocity of 6.28 meters per second, not even close to lifting him off the ground.
Our efforts to recreate Thor's mighty ability to simulate flight were flawed, as our unparalleled strength betrayed us.
Unfortunately, we could not complete a full rotation as 42.3 times proved too much.
Thor is able to hit objects extremely hard, in some instances hard enough to dent Captain America's nearly indestructible vibranium shield. Can any
mortal man achieve this feat?
Thor, with his mighty strength, is able to swing his hammer at 6 times the speed of light, meaning that we can use the conservation of momentum law to determine the velocity of an 80-kilogram man after being struck by the mighty hammer Mjolnir.
To do this, we took m1, the mass of Mjolnir, multiplied by v1, the speed at which Thor could swing his hammer,
plus m2, the mass of an average man, times v2, the man standing still, equal to
m1, the mass of Mjolnir, times v1 prime, the speed of Mjolnir after the collision with the man, plus m2, the mass of the man, times v2 prime, the velocity after the man is hit.
We rearranged to solve for v2 prime.
By doing so, we determined that after the collision, the man would be traveling at a speed of
3.4 times 10 to the 8 meters per second. When Thor flies to missions, he feels a gravitational potential energy on him. If he is flying at 3,000 kilometers above Earth's surface, you can find the EG. This would be done by taking the gravitational constant and multiplying it by the mass of Earth and the mass of Thor. You would then divide the product by the radius of Earth plus the height of which Thor is flying at, to get 3.16 times 10 to the 4.
Thor, being the god that he is, possesses unrealistic strength.
Unless you truly are a god, none of Thor's feats are truly possible.